All right, so we're back here again, and hopefully you guys have been kind of enjoying the videos. It's sort of like being in a classroom, right? That we're seeing back on it. I really enjoyed doing them, so hopefully we'll like it. So we're starting. This is with our fourth module. We're getting close to the end here, and this is all about confidence intervals, which we'll call CI. And that's mostly what this chapter is about. Is basically what we're trying to do here is express uncertainty. So the big thing that we want to do here when we're thinking about this, right, is that we always have estimates. So when we think about when we draw a sample, we know that even if it's randomly drawn or something like that, this may not equal the population parameter. And, so because it is an estimate, we want to know how wrong we are. And it also gives us an idea that if we get a value that doesn't meet expectations, we'll know whether or not to raise an eyebrow. So what we're talking about here, right, is that just like a key little bit of things, right? So when we think about points, this is going to be things like a mean, right? And we think about an interval, this is going to be like a range of values. And just as a brief illustration here, so let's say, for example, I had this mean of 3.5, right? And this was going to be, it's like right here, and I have this number line right here, and we'll say, like this is -1, 0, 1, 2. The scale doesn't really matter, right? So just like, if you're like, it doesn't line up, like, just cut me some slack, right? Like, this is just a stupid example. An 8, right? So this would be like our point estimate is right here. And then based off of that, we may say that there's a range. So let's say it's right here, and it ends right here, right? So this is going to be our interval. And so what this in effect does for us is say we might expect a value between 2 and 5. That's more or less what we're doing. So these are useful because it gives us an idea of error. Because of the error, and we're not fixated on a point. So all this is good, right? So because of this, we refer to the interval so that we were just talking about is known as a confidence interval. And more often than not, like the confidence is going to be like our degree of certainty. So we might say this by saying that we are 95% certain. This is the amount that's used most often, that the population mean, or the mean that we're estimating, falls within a range. So that's usually what we do, and we sort of like look at this, right? How do we go about solving this, right? So as we've already seen, that there is a confidence interval formula, and if we were going to figure this out, right, we would use x bar. So this would be like the average that we're trying to estimate, and we know that there's going to be a degree of error positively and negatively, so plus or minus 1.96 times the standard deviation. So this point estimate, right, we're usually trying to figure out is like this mean. We use 1.96. This is a z-score that you will recall from earlier little bits, and this allows us to set up a 95% confidence range. And so when we think about like, and one last little thing here is like, how do we end up finding that confidence interval, or excuse me, the standard deviation? And we find that standard deviation is going to be equal to the proportion that we're trying to estimate minus the complement of that. So we multiply the proportion times its complement. We're dividing by the sample size, n, and square root, right? So a bit convoluted right now, so we'll go ahead and in this next video, we'll show, like, we'll work through some problems real quick.